Hey everybody, we're going to go ahead and update the rest of the notes. I know you did this example with a different video and it was pretty painful. I realized that, but I do want to let you know there's a different way that we can handle things like that. Now it looks like my pen is dead, so I'm going to do that. Grab my highlighter. You can solve these systems by graphing. Sorry for the background noise if you hear it. I'm at my house. Oh, and there's the cat. Okay. I need you to recall that when the variables of linear inequality, they represent the real numbers. A graph solution can consist of a half plane. So we learned that back in chapter 2, section 8 with shading. You also learned it in algebra 1. So we're going to take a look at this top inequality. It's linear. And the most important part about graphing is that we get y by itself. So I'm going to take 2x to the other side. And I'll have negative y. Negative 2x and minus 3, nothing new. Divide by negative 1. We've done this. We actually did this last chapter. Did this in algebra 1. Flip your sign because you divided by a negative. And now it's time to graph that inequality. So we're going to take this and we're going to graph it. We're going to use our normal graphing skills where we go up 3. And the slope was up 2 over 1. And that was a solid line. Again, if you need refreshing on that, please ask. Solid and shading below. There's that one. There's that one. And shading below. So that's everything here. You know what? I should use one color. I'm going to use purple to make sure that you know purple goes with purple. All right, now everything in purple, all of those individual points inside of there, all of those points satisfy the purple equation. But now I'm going to do this green equation too. So I'm going to get y by itself. So negative x. And I got to get y by itself, just like we always have. I'm going to shrink this one down over here. I'm going to do a better job of circling it. That way I have a little more room. Oh boy. Well, at least I gave you time to catch up with me, right? There you go. All right, so what do we get if we subtract x or add x? My daughter's calling me. Negative 2y is less than or equal to, she's still calling me, a positive 2x minus 2. Now I'm going to divide by negative 2. And that's going to give me a positive y. I'm going to flip my sign because I divided by a negative. Remember, there's a 1 there. So these are, again, just some old algebra 1 skills. Getting y by itself. If you need some more help with that, definitely make sure you stay after to get that help. So we're dividing by negative 2, and this is the result that we get. And I'm going to go through and I'm going to graph that. So start at positive 1, just like we have been. And I think it was down 1, right 2. Again, if you need some help graphing this line, I need you to stay after, or at least make sure that you tell me during class so we can talk about how to graph a straight line. But, all right, do this. Make sure that you really need to, some people, I won't name any names, but some people try, I swear, to make their lines as small as possible. Please don't do that. You definitely want to get your line as long through that graph as you can. And what are we shading on this one? We're shading above it. All right, so we have two half planes. We have the half plane that's purple. We have the half plane that's green. Anything in purple satisfies the purple equation. Anything in green satisfies the green equation. And maybe even further, you know that anything in this double shaded answer satisfies both equations. So everything inside of here, this is the solution area. There are an infinite amount of solutions in there. For example, let's pick an easy one. Like a really easy one would be 2, 2, right? Because it's like right smack dab and we can't screw it up. In other words, if you went up here and you put 2 in, you would get a true statement for the purple. Oh my goodness, my daughter's being so loud. I'm so sorry. And that would be true. Let's just check though, because that would be what, guys? That would be 4. This would be 4, take away 2, and that would be greater than or equal to negative 3. And if you plug 2, 2 in here, what would we get? We get negative 2 minus 4. And that's definitely less than negative 2. So what does it mean to be in this like solution set? It means that any point inside of this double shaded region satisfies both of the original problems. Like if you were to plug them in for x and y, or substitute them in for x and y. All right, just clean that back up. Now that got it's going to be the exact same way. Okay, so let's just go over the steps. Feel free to type these into Desmos to check. In fact, I might do that. So you're going to get this in y equals. You're going to get this in y equals, or in slope-intercept form. That might be a better way of saying it. I think I have Desmos right here. And just to make sure that you're okay, I would highly suggest that you do this. I'm certainly not going to sit here and force you. You know what you need to do. You know if you're struggling or not. So you know if you need to try to get this to look like Desmos, and then ask questions if you have them. So it would look like this. So if you graphed it, it would look something like that. And everything in this double shaded area right here, everything inside of here is a solution to those two equations. So I'm not going to graph this by hand. You will be required to do that, just like the top one. But to save us some time, I'm going to say, hey, if you're struggling and you think you need something, please graph it and make sure your graph looks like that at the end. Oh, some kids really think, FYI, some kids think that it has to meet at a perfect point. Like this one meets at a perfect negative 6 and a perfect 5. That is most definitely not the case. They can meet anywhere. Like see this one? These ones meet at a very random spot, and that's okay. That solution is, in this case, this solution is a solution because it's in a double solid area, but I don't know what that is. It's a random decimal, probably. I don't know. I'd have to solve it to see. Okay, now we got to do word problems. They do exist, and they're really important. I knew what the answers were going to be, so you can see I already drew my scales on my x and y axis. That's a skill you're going to need to develop as we move along. Your city's cultural center is sponsoring a concert to raise at least, so at least is greater than or equal to 30,000. Oh, if anybody did print this, you're going to want to keep all that over there. I'm going to shrink it down when I'm done. So at least $30,000, greater than or equal to $30,000 for the youth services. Tickets are $20 for a balcony seat. So $20 for a balcony seat. That is my husband filling up our water bottles for tomorrow. And that's my cat puking. I'm not taking that out of oh my gosh, what a mess. At least you guys know I'm human. $20 for a balcony seat and $30 for an orchestra seat. Now, I'm not going to use an O. I'm going to use a Y because if I use an O, it's going to look funny. So I bet you guys are probably wanting me to use an X if I use a Y there. Okay, so balcony seats, orchestra seats. So these are all prices, which is how I knew they went with the 30,000 because the 30,000 is the money we need to raise. Oh my goodness gracious. I'm not redoing my video. Okay, now one more stipulation, okay? Maybe you guys think it's funny, or maybe you think it's really gross. Either way, it is what it is. Right there is what oh dear. This, he's going it down. This center has 500 orchestra seats. So we have 500, but the orchestra seats are Y. So I really need you to think, do we have more than 500 or less than 500? Hopefully you're thinking less than 500 or equal to it, because you can't you can't sit more people than 500. It's either equal to 500 or less than 500 for the number of people you sit. So I'm going to put this over here. It is my hope that you remember how to graph this one. Okay, so I'm going to highlight this one in green. I'm hoping you remember to graph that it is a horizontal line. I'll write horizontal line here at 500, and it's solid. So here we go. Where's 500 going to be? It's going to be right in the middle of 400 and 600. So right there. My physics kids always tell me that they hate it when I do lines. There we go. It goes on forever in that direction. And because it says less than or equal to, it's everything underneath of it. So that was the first one. I thought that would be the easiest one to graph, the horizontal line. And now it's a horizontal line because there's no x. We talked about that in the last chapter. And really, guys, I don't need to be graphing anything here because you can't have negative seats and negative money. So you can erase that if you want. If you're kind of like a little perfectionist, you go right ahead. And actually, in all honesty, nothing in this area should be shaded. There you go. Now it's time to graph this one. Well, this one's going to be more of a challenge because it's not in y equals, but that's okay because we have those skills. So minus 20x. All right, and that's 30y greater than or equal to a negative 20x plus 30,000, 2, 3. And we're going to divide by 30. Grab your calculator if you're not sure how to do that, please. You will get y is greater than or equal to, I did not flip my sign, I did not divide by a negative, negative 2/3 x, and that's going to be 1,000. Okay, now it's time to graph. I did make sure that this is skipping by 200s and this is skipping by 200s, so that when I go down 2 over 3, it's legit, because it's actually down 200 and over 300, so it's okay to do that. Like, it still stays proportionally down 2 over 3 because that's the ratio. So here's 1,000. Look, I conveniently made it the top of my graph. Now I'm going to go down 2 over 1, 2, 3. See, down 2, 1, 2, 3. And that's okay because, oh, I lost it. 1, 2, 1, 2. I actually went down 400 and over 600, which is still, and if you want to, hey, Miss Angela, you cheated. 1, 2, 1, 2, 3. That's where I saw it, Miss Angela. That's great. That's totally fine because it would be down 1, 2, and then over 1, 2, 3. So there's nothing wrong with that. You can, in fact, maybe that's a better way of doing it. That's okay as long as you get the slope. I'm going to do that again, okay? But look, this time I'm going to go, because these are all ratios, I'm going to go down 2 over 3. There's a guess of mine that some of you are like, why did she keep changing? Ask me. If you're having trouble with that slope I just graphed, please ask me. I think sometimes, there's a general struggle when the slope is not, when like the axes don't count perfectly by 1. If that's you and you're like, I just don't know why she was allowed to do that, call me over and let me explain that to you, okay? Now that one was greater than or equal to, so anything, I want to change colors, anything in purple, greater than or equal to. So where's our solution set? And believe it or not, this was actually in Algebra 1. Where's our solution set? It's anywhere in this darkened area right here. So anything in that dark area, that black area I just shaded, that's a solution to both of my equations. And it says how many of each type of seat must be sold? Well, anything inside of there. So let's give a for instance. How about 1,400? How about that one? That's going to land right, where is that going to land? Land right there. That's an example, okay? So I could say, let me change that back. I could say 1,000 balcony seats. That's one solution. And 400 orchestra seats. So if you got sold that many seats, you would be making greater than or equal to $30,000. And you would not, like your orchestra seats would stay under the 500. So you would take care of both of those. Now this got it problem, what I wanted to do here is, yes, I do expect that you should be able to make the graph, but what I'm not sure you could do is make the equations without me. So that's what I'm going to do, is I'm going to make the equations. I love you too, Peanut. They're trying not to go to sleep right now. I mean, I could probably just teach them this lesson and it would put them to sleep. A pizza, oh my goodness. Nothing like a working parent, guys. A pizza parlor charges $1 for every vegetable topping, and you can see I call those X's, and $2 for each meat topping, and I call those Y's. You want at least 5 toppings on your pizza, and you have $10. So here we go. Let's deal with the fact that we have $10. To me, that's the easiest one to deal with, the $10. So I can't spend more than $10. This part right here, I think is hard for kids because a lot of times kids are like, hey, is it greater than? Is it less than? So ask yourself, am I allowed to spend more than $10? No, you only have $10. Well, what is my money? My money is going to go $1 for every veggie type topping, and I'm going to have to spend how much? $2 for every meat topping. So there you go. We have one stipulation. Everything here deals with money. I saw something else here, and it was at least 5 toppings. So at least means, let's see, you have to be at least 16 to drive. So that's greater than or equal to 5. So what is greater than or equal to 5? Well, the toppings. Well, what kind of toppings? Veggies and meat. If you solved both of these for y, and I would highly encourage you to do that, but to save you some time, I will tell you this is the equation you should get. And guess what, folks? If you're not able to get that, you need to come see me. And solving this one for y, you would get y is greater than or equal to negative x plus 5, okay? Again, if you can't get that, please let me know. I don't want to spend a ton of time on like basic, like the understandings that we should have, okay? And wow, I even conveniently like graphed those in the correct colors 100% by accident. So my blue line was this line, and excuse me, my blue line, let's see, what did it do? It started at 5, it went down 1 over 2, down 1 over 2, down 1 over 2. So that was my blue line, and it said it was less than, so it's shaded below. I'm so impressed with myself that I randomly chose the right color. And then my green line was at 5, and it down 1 over 1, down 1 over 1, and it was shaded. It was said greater than, so how do we shade greater than? We shade above, okay? So it would be up here. So let's label a couple of possible solutions. So with these stipulations, the fact that you won at least 5, the fact that you only have $10 to spend on the toppings, what's one viable solution? Anything in here. So let's pick a random one, shall we? Let's pick this one. So you can get 6 veggie toppings. And what is that? 6 and then 1 meat topping. So I'm getting 6 veggie toppings. I'm getting 1 meat topping. All right, pause that, rewind it if you need it. Now, problem 4, I knew I could do this. I tried to shorten the video as much as possible for you. I'm excited. Problem 4 is going to deal with linears with absolutes. But guys, we've done this. We did this last chapter. All we're adding is shading. Okay, in chapter 2, in chapter 2, no, actually in chapter 2 we did shade, didn't we? What happened is that now in chapter 3, we're marrying chapter 3 with chapter 2. So we're solving, we're saying when are they equal with shading. So goody gumdrops. Do you guys remember how to do this? I hope so. It's a horizontal line because there's no x. So let's go to where 3 is. And what did that say? Did that say shade above or below? That one says less than, so it says shade below. I'm really hoping you're seeing how chapter 2 and chapter 3 are uniting here. So that would have been chapter 2, but now chapter 3, we add in the second one as well. Oh, buddy. So minus 7, you have to get y by itself. You must. Oh, that's neat. Look, it just takes the 7 off. You cannot do minus 7 here because this is protected by absolute values. I'll repeat that because I have a feeling I did that fast. You cannot do minus 7 inside because it's protected by absolute values. All right, now this is a V shape. How do we graph V shapes? Your vertex is positive 1, comma 0, because there's a 0 back here. Okay, I'll highlight that so you'd like just remember that was like implied. And your slope is the 1 in the front. Again, I'll highlight that because that was implied. Let's go graph this V shape. So positive 1, 0 is right here. And it had a slope of 1 over 1. And you got to make it a V shape. It is shaded. It's going to be shaded above. I'm looking right here, folks. Okay, right here. It's going to be shaded above, and it's going to be solid. Shaded above and solid. So here's that. Here's this. Let's get some shading. There's above. You'd learned that in chapter 2. And now it's time for some solutions. The solution is anything in here. Please be aware that on SATs, they might only have that part shaded. Okay, so this graph is acceptable, or just, let's see if I can do that an acceptable way. You might see that on the SATs. Okay, just in case, because not everything, a lot of times we think everything's so copy and paste, and it's not. So I think it's important that I tell you in the SATs, that might be the answer, just the double shaded region. So it could be all three, or it might just be the double shaded. So please be aware of that. All right. What are some solutions? Well, how about over 1 and up 2? That's the solution. How about, here's a good question. What about 1, 0? Do you think 1, 0 is a solution? Well, it definitely is, because it's on a solid line. Now, if it was on a broken line, not a solution. What do you guys think about this one? What do you think about 2, 3? Yes, it's on a solid line, so it's a solution. What about their intersection? Yes. What about -2 and -2? No. Okay? So anything in the double shaded region, let's say it one more time just for good measure, because I'm not sure how it's going for you. So I'll say it one more time. Anything in the double shaded region will plug in here and be true, and plug in here and be true. So you would get like 1 is less than 3, or 2 is less than 5, or 5 is greater than 2, something like that. And that is a lesson in a nutshell. I'm okay. If you feel like you're good enough, you can stop, but I'll do this last one just for good measure. That way I have a solid answer key, okay? If you wanted to solve this one, okay, I'm going to do this one fast. I would add the 1/3 to both sides. And yes, that is an Algebra 1 skill. I hope that you're okay. So I'll highlight it. I took that to the other side by adding it. Now I'll divide everything by -1. I'll flip my sign and divide everything by -1, and I will graph that. Just going to change color first. This one's a V shape at +1, 0. You need to let me know if you forget how to do this, okay? Because that's very important. If you forget why it's a V shape, it's because it's absolute values. I'm going to graph the black one. Yes, I'm moving very fast. So what you might want to do, if I'm moving too fast for you, pause the video, try it yourself. And then play the video, maybe even play the video slowly. This is our first broken line of the day, isn't it? Let's extend that. And this was a line, it was not a V. I'm going to shade lower than that line, so anything here. All right, now I'm going to get the V on there. Over 1, up 0. Oops, guess I should probably use a pen there, huh? All right, there's my vertex. What else do I have? Slope is up 2 over 1. And that is broken and shaded above. There's broken. There's broken. I noticed in the homework some kids are not using arrowheads. Please do that. And then shaded above is, in this case, everything inside. That's where above is. Above the vertex is inside on this one. Oh my. Oh dear, that is a tiny solution set because it's just where the gray and the purple overlap. So it is this tiny little area in there. I'll circle it because it's almost so small you can't even like highlight it with the highlighter. So it's this tiny little V-shaped area there. So maybe I could say, what would fit in there? Over 1. And not 1, 0, because that's on a broken line. How about over 1 and up 1/2? There you go. I know it seems crazy. There are actually infinite amount of solutions inside of there. They're just so minuscule. Like, for example, maybe 1 and 0.55. So there are a lot in there, but boy, that is a tiny little answer there. But yep, it is what it is. Okay. Yeah, just millions of minuscule answers. All right, so here's your goal, guys. Number 1, are you able to do what you did in chapter 2? In 2-8, are you able to graph lines? Are you able to graph V's? And are you able to shade? And then we bring that together with 3-1. It's where like the intersection happens. And in inequalities, it's the intersection of the shading. So, big takeaway, do you know why these are inequalities? Why do I keep using the word inequalities and not equations? Well, because they're symbols like this. So when they're inequalities, it's all about the shading and where the shading overlaps, and there are millions and millions of answers. If the shading does not overlap, there is no solution. All right, might have to put that in there somewhere. I'll see you later.